Hi everyone. I am Zaining Chen from University of Chinese Academy of Sciences. It is my honor to be here and talk about our work, characterizing Flaky tests in Node.js applications. After the developer submitted the code, he ran the test cases and found that the test cases sometimes passed and sometimes failed. We call this kind of test case that sometimes passes and sometimes fails on the same version of the code as flaky tests. Debugging bugs that don't really exist is a waste of time. Developers don't trust test results. For example, first create a server via HTTP create server. Next, create a connection to the server and initiate a request to the server through the connection. Then, the server sends back a response. Finally, the server shuts down. This is the execution order of the test case passing. However, due to the lack of synchronization of events by test cases, the server shutdown event may be triggered early. This will cause subsequent events such as connection creation to fail and the test case to fail. Existing flaky test studies focus on different programming model features from Node.js applications. In addition, flaky test study on Node.js applications coarsely divides flaky tests in Node.js into concurrency, async wait, and other categories. Since non-determinism inside Node.js applications distributes from OS level to application level, it is still difficult to design flaky test detection approaches under the coarse category. To solve above problems, we come up with a research question: what kind of non-determinism causes flaky tests? Then, we conduct a study. We collect 87 flaky tests caused by non-determinism from existing work. We perform in-depth analysis of each flaky test and record all steps to reproduce flaky tests and construct the flaky test dataset. According to our study, we find there are 5 kinds of non-determinism that can cause flaky tests in Node.js applications, including non-deterministic event triggering order, non-deterministic function calls, non-deterministic process thread scheduling, non-deterministic execution of async tasks, and non-deterministic event triggering data. For example, the parent process creates a child process through child process spawn and registered a timer event through setTimeout. The data event is triggered when the child process sends data to the parent process. The data event cancels the timer. However, the timer event may trigger execution before the data event, and an exception will be thrown when the timer event is executed. As a result, the test case intermittently fails. We also found that non-deterministic function calls cause flaky tests. A non-deterministic function call gets a non-deterministic return value. For example, the test case calls the now method to get the current time and assigns it to the variable first. After a period of time, the test case calls the now method again to get the current running time and assigns it to the variable second. The values of the variables first and second are non-deterministic, which may violate the assertion and cause the test case to fail.
Non-deterministic event triggering data causes 6% of flaky tests. For example, the test case creates a server. When the server starts listening, it sends an upgrade request to the server to change the protocol. When a request reaches the server, event is triggered. Event sends a response. After receiving the response, the event is triggered. Event determines whether the received data matches the expected string NIER. However, if the response data is not in the same data block and the received data is not the string NIER, the assertion fails and the test case fails.
Based on above findings, we conclude that Node.js applications have a wide range of non-determinism to raise unexpected executions, causing flaky tests. Existing event risk detection approaches are not sufficient to detect flaky tests. Researchers should take various categories of non-determinism into consideration to detect flaky tests. Thanks for listening.